Welcome back to the workshop. It's been a while, but I've got an excuse. I couldn't be bothered making any more videos. And there's been a bit of an extension to the Burn Engineering workshop. But more about that later. Looks like Targa Tasmania is back on in November, so we've got some work to do on the Stratos, starting with a bit of a front suspension upgrade. This is the original bottom arm that came with the Stratos. I pretty much used this as is. I made a few modifications, but it was pretty much as it came on the car. It survived a full day of Winton testing, but about halfway through our first stage at Targa High Country, this angle decided to significantly decrease. Now, we spent about 4 hours in the car park of the local service station disagreeing with that new angle. And when I got home, I created this sort of exoskeleton around the arm to really cement home that this was indeed the angle that we were after. Now, this all does work, but it's starting to look a little bit like I sent it down to the local blacksmith to be reshoed. I'm also not super happy with the caster arm mount that I made. So why did it fail in the first place? Well, it pretty much comes down to the bending load that's been created because the spring isn't acting directly on the same point that's mounted to the upright. So we've got quite a big bending load from the spring. We've also got a bending load from cornering because we don't have a direct load path from our bottom of our upright to the body mount. This bend needs to be there to clear the body, so we can't do much about that. And we can't do much about the motion ratio the spring needs to mount here. So the only thing we can do is make the whole thing stronger. So we're going to start off doing that by machining out a billet section to replace this ball joint with a M18 spherical bearing. So I haven't got any decent reference faces yet, so I'm using the scribe line, the centre scribe line, just on the top of the vice jaw to start us off. We'll machine a flat here and here, flip it over, use this as our next reference face. Now we can use this as a reference face and hopefully keep everything relatively parallel to start with. Ow. Like it. Now, I'm going to help myself out to get this thing centered on in the lathe by putting a center punch for the tailstock. That doesn't look very good. What's going on there? They were fucking close. Ugh, that's not the scribe. Wow, really fucked that up. We might do this on the surface plate, I think. Let's try this again. There we go. Bang on 34. Makes life easy. Alright, I've probably got my fat head in the way, but looks like we've got it pretty good this dimension already. Okay, I might set up the dial indicator as well. Now it's a low point, we'll zero it there. Ooh, it's pretty good. Tweak it. This way. Fraction. Yeah, bang on. All right, I think we can finally do some machining. It's looking a little bit more respectable. I think it's time to take some gravity out of it. Now I want to put the angle on the end that will meet up with the tube where we weld it up, and that's 8 point something degrees. I'll go and check, but we'll put that in the vise. Whoa, that's 0 degrees. I've referenced this to the mill bed already. 13, that's too much. 12. We are going for 8.7. Okay. We need a nice machined hole for our M18 spherical bearing. I haven't got a boring bar for this mill, and to be honest, it'd be pretty useless anyway because I haven't got power feed. So what I'm going to do is use the DRO to pick up the center and also the 112 millimeters from this end. Then I'll punch a hole through with this nice rotary broach, and then it'll give us a good reference point to take it over the lathe and dial it in on the forge jaw. I do like that style of edge finder. The only problem is it needs to run quite quickly, and all my tools need to run quite slowly, so I'm forever changing speeds with the belts. So I've checked it with the indicator. It was a bit out, but it's all dialed in now. Guess we should talk about this. I've kind of ended up with a 3-jaw chuck because I can't really fit the 4th jaw in. Now I will be running the lathe at a very low speed because it's a bit unbalanced anyway. I've done these 2 jaws up really tightly and they've got some really good purchase. Once the boring bar's in there, the part can't really go anywhere. And to be honest, I mean, this isn't much heavier than a chuck key, and it's not like I haven't fired one of those across the room at warp speed, so I'm sure it'll be fine. Certain death avoided in the lathe. Now it's time to put a nice radius on this end. Broken out the rotary table, zeroed the part to the rotary table, and then zeroed it to the spindle. Whoa, that is way too fast. Right, now, how do I use this thing again? I can go this way. Which way is climb cutting? Because we don't want to do that. So we're almost at the point where we can start joining some of these bits together. Here is the offending arm. and I've made this jig up to sort of replicate some of the geometry. An aluminium bush there to replace the rubber one, and I've set it up so that the top of this is horizontal to the bench. Also drawn a line to keep everything square, and couldn't really come up with a great way of holding this bar stock to the bench, so I've sort of encapsulated it with some hardcore magnets from an old hard disk. So we've got our new arm. I've turned a little boss down so that it centers on that, and then we can just screw that into place. And then turned up another little ring that will take the Nilesane bush. So all we need to do is a bit of bar from here to here. Of course, right underneath everything. So I'm just going to cut a little bit off. So there's a 8.7 degree angle there, and then a fish mouth on here. I've already cut the 8.7 degree angle. I've measured from the center line to the edge of the bush, and now what we need to do is just drop a fish mouth into the tube. Centered our hole saw on the tube. We've got our 8.7 degree angle here. This obviously needs to be indexed so that the hole is in the right orientation compared to the angle. So I've set up these blocks and lined it all up so everything is, well, not square, but there's no gaps there, which means that this is at 90 degrees effectively to the hole saw. Well, that's the theory anyway. Let's see if it works out. So now I've just got to get our measurement from here to here and do a fish mouth. I think it's 241 millimeters. That fits in there really nicely, which is great because the first one I made was 2 millimeters too short. Time to tack it up, and I've also got the beginnings of the new caster arm on the other side of the bench ready to be tacked up as well. Turn the gas on. I did. Guess that's not working. There's still nothing. Oh yeah, need some electricity, don't you? There we go. Oh, fuck! Man, this thing is fighting me every step of the way. It's my fault, I should have tacked both ends rather than one end completely. Take two. So I've knocked up a couple of these little tags, and they will connect our caster arm to our main bottom arm. So I'm just going to tack this into place. I've got it sort of sitting there with an array of cable ties at about ride height, and this is where the hoist comes into its own. Yeah, finally remembered the ground clamp, but forgot my filler rod. Got our caster arm bracket welded to our bottom arm, and the bottom arm's back in the jig because we've got a couple of small issues to address. The first is I haven't finished welding this arm up. The second is this hole is way too small for our M18 spherical bearing. For a change, this was done on purpose. I was worried that if I machined the correct bore for our spherical bearing, which has to be quite a good close fit, that after we punched in that much heat, it was going to warp the bore. It might have been alright because there's a fair bit of meat there, but I didn't want to take the chance. So the plan is to unweld our bottom arm and throw this part of it back in the lathe. You can imagine this could be a bit of an issue if I tried to mount the whole thing in the lathe. One bottom arm unwelded. Slightly less sketchy arrangement this time. Rather than holding it directly in the forejaw, I've made up this little mounting plate. There's a boss here that will register against our current hole. And it should mount like that with this little cage to hold it all together so we can bore out to the appropriate size for our M18 spherical bearing. I've said M18 spherical bearing a lot. That's not going anywhere. I guess you're wondering why I didn't use an arrangement like this initially. I needed to be able to bore right through for the first part of this hole, but for this section I only need to bore down a certain depth and leave a lip to stop the spherical bearing pushing all the way through. 3mm lip off this face, so I've just got a bit of 3mm scrap there as a gauge, and I've set the lathe stop to that so I can't machine too far in. We are going for, well, the bearing is a 35 nominal bearing. It measures at 34.98. We want a fraction under that. I'm going to go for 39.9596. So really light press fit. Spherical bearings can't deal with a massive press fit because it compresses the outer ring and stops them being spherical. Or stops them being a bearing. I guess they're still spherical. Probably make sure it doesn't hit anything first. Safety glasses. Oh yeah, I forgot it. I forgot it was a little bit unbalanced. Maybe that. Yeah, I can deal with that. This could take a while. I'll see you soon. We're at 34.94. It's fractionally under what I was going for, but I think it'll be fine. If I have to touch that with a little bit of emery before we press it in, we can do that. On to the next stressful component, which is the O-ring groove. The circlip groove. That needs to be 16.5mm off that back face. I've got a little gauge block set, 16.5mm. I've learnt to put a little bit of scrap shim stock there so I don't gouge out the gauge block set with the tool, and I'm just going to bump the tool up against the gauge block set to get exactly 16.5mm off the back. Reattach the arm. I think the surgery was a success. Getting dangerously close to finishing now, but we still need a mount for the spring and damper. It's going to live in this area here. So we need some gussets, something like this. I've got them spaced apart and parallel with a threaded bolt and some nuts, as opposed to an unthreaded bolt, I guess. And another fairly dodgy setup. Keeping the foot parallel to the table with this clamp, and then this 90-degree block should square up or keep the gussets 90 degrees to the foot. I'll just place it there, like that. This little mini clamp in here, just to snug it up. And I'll tack that together and we'll trial fit it in the car. Had it back in the car. Amazingly, it does fit. So time to weld it up. So our bottom arm is done. Or I thought it was done until I sat down and had a safety beer. And while I was staring at it, I decided I wasn't super happy with this sharp transition point at the end of this gusset. It'd be nice to have a bit more of a direct load path coming from our bottom ball joint to our body mount. I found some thinner wall tube and cut this slither off it. And I reckon if we add that there, create some sides to close it all off, that will help me sleep at night. Probably not required, but for the minimal amount of weight it's going to add, I think it'd be a nice addition. So I'll tack it on, we'll throw it in the car, double check that there's clearance to the body. Assuming it all fits, we'll cut some sides out and then weld it all up, and then it will be done. And then it'll be time for another safety beer. Plenty of clearance, so on to making some cardboard templates. Now I'm not going to lie, they took quite a lot of tweaking to get them to fit properly, but I guess you should stop whining about it and just tack them in. Quick trip down to the powder coater. And by powder coater I mean the satin black rattle can. Looking pretty good. They won't look like this for long. Let's put some bearings and some bushes in. So as we're using the original Fiat upright, we can't just use an 18mm bolt into the upright as the original ball joint is tapered. So we need a fitting with an 18mm shank on one end and a matching taper on the other. The hardest part of this was single point turning the M14 by 1.5mm thread. This was made even more difficult as I'd left my change gears set up for an imperial thread, and it only took me about 1 metre of bar stock to work it out. Anyway, it's probably overkill, but I'm using some 4140 chromoly for this part. That was a huge amount of work, but very happy with the result. Our connection to the caster arm is super strong. I don't think we've got any potential for our bottom arm bending again. That fitting I turned up on the lathe to go from our spherical bearing to the taper in the original upright worked really nicely. Nothing left to do but throw it on the ground and do an alignment, and hope I haven't screwed anything up. After a safety beer, of course. So I'm sure some of you are wondering about the weight of the new bottom arm. And I'll admit, the new arms are fractionally heavier than the arm we pulled out of the vehicle, but they are a hell of a lot stronger and a hell of a lot safer. And I've got to admit, after our first failure of this arm, I struggled to trust the vehicle, which is not something you want on a rally car. We're only talking about a couple of 100 grams, and I've got a plan to maybe recoup that weight in another area on the front suspension. Anyway, I think that'll have to do for this episode. I've switched to the old James Bogues Premium in honour of Targa Tasmania being back on the calendar. So till next time, thanks for watching.